Hello everyone. In this new series of videos, Parallel Systems is searching the globe for a new technology that can help you build better designs quicker, faster, and with more confidence. The company CADY reached out to Parallel Systems and with cool technology that we think you should know about. So in this video, we're going to see a demo of the tools, but also a quick interview to get to know the CADY company a little bit better. Here with me today is Tal from CADY. And Tal, thanks for taking the time to show this to our friends. We really appreciate it.
Thank you for having me, Simon.
No problem. So in your own words then, do you want to tell us what CADY is all about?
Yeah, of course. So CADY is all about using AI to help board designers design their boards better. So when we look at other disciplines like software engineering, for example, software developers have static analysis tools that find errors within their designs. Even in informal areas like writing an email. When I write an email, I have tools that find errors, automatically catch them and offer me some replacement. Now, board designers do not enjoy this luxury. They have very limited tools that can check them, and they suffer from it. They have a lot of mistakes, and it takes a lot of time to find them. And what CADY does is use AI to read data sheets of electrical components, we'll get into it in a minute, and use this information so we can do real analysis and find errors early in the process.
Okay. Now, I'm all for the most rigorous design checks that you can do on every design as soon as possible. If there's a new way of design review using AI, I think our customer base would be very keen to hear about it. Most design tools do come with those design checks built in, right? And most people peer check the designs, as you said. Isn't that enough? And how does CADY add to all of those existing checks?
Yeah, that's a great question. So when you use a CAD environment like OrCAD or Altium or any other one, you get a DRC, a design rules check, that performs automatic inspection, and they're great tools. We're all for them. But the thing is, they're really narrow in their scope. So what does a DRC really check? It checks things like floating pins or a connection between input and input. So very basic mistakes, I would say. And the reason for that is not because these tools don't have electrical knowledge. It's because they're missing important information. So in order to test for complex mistakes, like a communication protocol mismatch, a wrong voltage, a connection instruction violation, any of these alerts and many more, you need to understand the components. And you can't do that without reading datasheets. But the DRC has only the information that you inserted into it in the component library. That's why DRCs are a good first start, but they don't cover about 99% of the errors that actually happen in real life. And that's where CADY comes in and add to it.
Okay. And can you explain a bit about what is needed from the designer? What do they need to send you?
Yes, so the key thing here was to make a product that is as easy to use as possible. So basically, this is a drag and drop product. All you have to do is export a netlist from your CAD environment, export a BOM, a bill of material, or prepare a BOM, and just drag and drop them to the SaaS application. So it goes up to our servers, it is analyzed, and you get a report. You don't need to manually insert any information. So running CADY can be a matter of 2 minutes. We'll see it in the demo shortly, and no effort is required from the engineer.
Cool. Okay. So obviously everyone considers their designs, their security of their IP, not wanting to be put out there onto the cloud. Can you tell us a little bit about the design security? What's in place and what's involved?
Yeah, so that's really a key issue. We hear it from all our customers, and we have customers, large multinational corporation dealing with very sensitive IP. And of course, everyone is concerned about uploading designs to the cloud. The key thing we do to remediate this issue is the fact that we don't save the files that are being uploaded to our servers. So you upload your netlist BOM, they are being analyzed and deleted, purged. You get a report, and CADY does not have your design stored within our servers, and so there is no risk of them being leaked or misused in any way. We have a very comprehensive security white paper, which tells you can go into our website and see the fact that I just stated, that we don't save the designs, as well as more standard security measures we use. And I'm very proud to say that this type of work allowed us to pass the compliance test of all clients we worked with, including Intel, which is now a paying customer, and many other very large companies. So, of course, it's an important issue, but we believe that this addresses it.
Okay, brilliant. Now, CADY offers one free design review for the first time experiencing the CADY software, so that's really cool. Two things. If you're looking to do this, guys, please use the link that's in the description below. That way, CADY know you came from Parallel Systems. And CADY has kindly offered to do a special discount for Parallel Systems subscribers. So that's awesome. So please register and get in touch with CADY before uploading. Have a chat with them. Meet and greet their team. They'll help you quickly optimize the design check so you get the absolute most out of it. And like I say, it's for free, but please use our link in the description and get in touch with them quickly to optimize that. Okay, great, Tal. Well, you've kindly agreed to show us a demo of CADY. I'm ready to take a look at that now. And if you're ready, I'll hand over to you.
Okay, so what you see here is a real-life schematic sent to us by one of our consultants. And this schematic, you can see it here in OrCAD Capture by Cadence. By the way, this tool also works for any CAD environment. If you're using Altium or Mentor Graphics, it will work just the same, but we'll see it in OrCAD. So this schematics is about 6 pages, and that's, I would say, a mid-size schematic. So CADY checks everything. It doesn't matter how complex your design. We've checked designs of 1 page, and we've checked huge designs of 90 pages. It doesn't matter. So you see here a real-life schematic, and it has some errors, and these errors are very common. I'm sure all your viewers are familiar with these kind of errors, maybe experienced it themselves and felt the pain of having them. And if I run, we talked about the DRC earlier, if I run the DRC of Cadence or Altium or any existing DRC, it will not catch most of these errors because it lacks this information from the datasheet. So as we all know, to check this design right now, you need to go over the design line by line, net by net, pin by pin, marking lines, making inspection. Very difficult, and things are still getting missed. So CADY is another layer of defense that's very easy to run. So basically, if you want to use CADY, all you have to do is just export the netlist. So you export the netlist. In OrCAD, we use the .dat files. You see it here. There is also a guide in our website on how to do it. And you need a bill of material. You don't need any special template for it, just your own bill of material, as long as it has a part reference column and the manufacturer part number column. So the system can know for each component what is its datasheet.
Okay.
Once you exported these files, you can now go to our webpage. And as you mentioned earlier, everyone gets 1 free trial. So I encourage you, sign up. You can try this yourself. Doesn't cost you anything. You log in, it's very easy, and you get to this page. Now, as you see, this is a very simple page. It's not a complex tool to work with. You don't need to insert any information manually. All you do is you choose the name of the board you are developing. You upload the files. It's really a drag and drop process. You just upload your netlist, upload your BOM, and you are good to go. Now you can start the analysis. Now the system will read your files, validate that it understands everything in the way it's structured, and then gets you to this page, which basically tells you we are now undergoing analysis, meaning every component in your design is being compared to the information that the system passed from its datasheet. And if there is a mismatch between what the manufacturer requested in the datasheet and what you actually did as appears in the netlist, then you will get an alert. So now the analysis is running, and in this phase, you don't need to do anything. So basically, you're done. You're just waiting for an email. You can close the browser if you want. You're just waiting for an email that tells you the analysis is done, my report is ready, and shows you a link to the report. The email tells me my report is ready, and here's the link. I click on it. It's as simple as that, and I get to my report. I can see my reports in the application as well. I can see previous report, but the easiest thing is to just go directly to the latest report with the link. And I get this report. I can work on it here on the browser, or I can download it as an HTML or Excel if I prefer to work on it on my computer. And basically, the report is comprised of 3 major parts. So one of them is the configuration parameters. You can go and tweak things if you want. It's optional. Tweak certain things to make the inspection tailored to the way you like to work. What do you know about your board? What best practices you want to enforce? So that's one part. The second part is what we call the coverage table, or the supported components table. Basically, you can see each active component in your design and whether or not it was supported. So supported components means we had the datasheet and we were able to parse it. Our AI could parse and understand it. Sometimes some components we don't have their datasheets, or they are just too difficult for the AI to read at the moment. As you can see, we're very transparent with our users. We let them know exactly what is supported and what is not, so they know what is checked. We cannot guarantee 100% coverage. There are always some components, the datasheet is too hard to find or too hard to understand, but the typical coverage in a design that's being analyzed is about 90%. So you can expect the vast majority of your design to be inspected, and you know what part is not inspected and you need to do it yourself. So that's the coverage part. And the most interesting part is, of course, the findings table. So here the system tells you everything that it found potentially wrong in your design. It tells you where something happened. So C41, pin 2, U4, pin 14, etc. Which nets, which components. So it's very easy to locate the problem. And it tells you what went wrong. So we have a very wide list of categories of errors that we can find using this tool. We're always adding more and more to them. But the list already is very comprehensive. And of course, we can share it with any user who's interested. It can be a capacitor that's about to be breached, or a communication protocol mismatch, like clock connected to data, a missing pull-up, wrong voltage, and many, many more. So if up until now, the user doesn't have to do anything, they export the netlist, they drag and drop the files, and they just wait for the report. Now there is a very minimal amount of work you need to do. You need to go over the findings and check if this is something you want to fix. So basically, there are three options for each alert. Number one, it could be wrong. So we all know AI sometimes gets it wrong, misunderstands something. It happens. It doesn't happen very often, but it happens. So some of the alerts in a report will be incorrect. It is possible that the alert is technically correct, but you intentionally decided to deviate from what the manufacturer wanted. In your case, you want something else, and that's of course fine. And the third option is, this is a real error you need to fix. Now, this is something that happens all the time. In over 65% of the designs that our AI system inspected, it found at least one error that the designer said, this is a real major error, I'm fixing it based on the inspection. So the return over investment here is really very large. You spend very little effort, and with high probability, you catch errors that otherwise could take you weeks or months until you find them in the bringer. So you go over the alert, you check what is correct and what is not. You can mark it if you want to skip it. You're fine with this alert, you waive it, or if it's a real error you need to fix, you mark it as need to fix. This trains our AI to get better, and it lets you know what is okay with you and what is not. So if I skip an alert and I run the project again with the same project name, it will already be skipped. So I don't have to check things again and again. So just to demonstrate it on one of the flow on one of the alerts, so let's look at index 9. So we can see that the system tells us that on U1 pin 5, in a component called TPS 61165, there is a connection instruction violation, meaning the datasheet said you need to do something with this pin, and we didn't comply with that. And what we didn't do is, this pin should have been connected to ground via capacitor. We need a capacitor to ground. Now, in some cases, you just need to open the datasheet and see if that's correct. In many cases, the system even pinpoints you to the location in the datasheet from which this instruction came. So you see this icon, and it gives us the description, and we see the sentence, connect an external capacitor to this pin to compensate the converter. So it really tells us why the AI said so. We can see right away the AI is correct. We need a capacitor to ground. And then all we have to do is go back to the CAD environment and see what we did with U1 pin 5. So I can go there and immediately see that I connected it directly to ground instead of via a capacitor to ground. So it's a real error caught by CADY. I should mention, by the way, these things can be even more subtle. Like maybe I did connect a capacitor, but the datasheet wanted a certain value for the capacitor. We can check that. Maybe the rated voltage for the capacitor is incorrect. We can check that. Maybe the type of the capacitor should have been ceramic or something else. We can check that. So basically, any instruction from the datasheet that is within our scope, we can compare what happened in real life against what the datasheet wanted, and alert if there's a mistake. So I find the error, I see this is a real error, I fix it. So I just add the capacitor. So basically, all I have to do is just add a certain capacitor. And of course, I should choose the proper value, etc., but just for the demonstration. And now I can export a new netlist and go back and run CADY again. Now, it's important to understand that CADY's business model does not charge extra for rerunning the same project. Okay. So you run it again, it doesn't cost you anything. You see that you really fixed the error. You see that you didn't create new errors on the way, because sometimes people, fix one error and induce another. And you go through this process again and again, takes you minutes, as you've seen, until you get a clean report, meaning either no finding or all the findings are waived or skipped. Once you get a clean report, that means you have the green light to move on to the layout and then the bringer. And that's really the change that CADY brings to this world. we do a shift left of where in the process errors are being detected. You find the errors here early on in the process, and you save all the time and money of going through more and more iteration, more and more respins. And of course, you improve the quality of your products, because some errors are so subtle you don't even catch them on the bring up, and then they might hit the market with inadequate design. So that's it. Very easy to use and nothing special. And that's it.
Really cool. Well, it looks awesome. It looks very simple to use. It's just a netlist and a bomb that's going up into the service. It seems a very, very quick analysis. Excellent. So everyone, just to remind you, CADY offers one free design review for your first time experiencing the CADY software. Two things, please use the link, our link in the description below. That way CADY know you came from Parallel Systems. And there's obviously a special discount for Parallel Systems subscribers, so thanks for that. Please register and get in touch with CADY before uploading. Have a chat with their great team. Make sure they optimize that design check so you get the absolute most out of it. And all just to say, Tal, great software. Really appreciate you taking the time out of your busy day to share this. We wish you every success, and thanks for creating something really cool. We love it.
Thank you very much, Simon. It's a pleasure to be here, and it was a real pleasure chatting with you.
Excellent. All the best. Thanks, Tal.